Welcome to the 1 on 100 episode for engineering geeks and gate aspirants, starting with the introduction to data structures and algorithms. Let us look onto the topics that we are going to discuss today. We'll be looking into the variables, data structure, algorithm, structure of an algorithm, properties of an algorithm, abstract data type, data structure classification. Algorithms and data structure. Algorithm is a process, procedure, method, or recipe. Now, the algorithm and process do differ in certain ways that we'll be discussing in detail in the further episodes. Data structure is intrinsically connected to the design and implementation of the algorithms. The data structure deals with the study of methods, techniques, tools to organize or structure the data. Or, in other words, we can say that data structure is a particular way of storing and organizing the data in a computer so that it can be used efficiently. You can see three boxes in the slide. One box contains some numbers, the other holds some alphabets, and the third one holds the boolean, that is, yes or no, true or false. Now, what are variables? Variables are synonymous to the placeholders or boxes for holding of data. Now, in the programming languages, we use the variables to hold different types of data. Let us now talk about a general overview of the data structure, or you can say some common terms that we use with the data structure. The foremost is the data type. Now, the type of values that variables store in a programming language is known as a data type. In the previous slide, we saw the example of the boxes holding some values. So, the one that was holding the numbers is a numeric, a number type. The second was the character type, and the third was the boolean type. So we'll be discussing these more in the coming slides. The second was the data object, the list of elements. So if I say that there's a list of numbers, that becomes the data object. Very important part of data structure is the abstract data type. Abstract data types are the data objects that comprise the data structure and their fundamental operation. It promotes the data abstraction, focusing on what a data structure does than how it does. Basically, it is not really concerned about how it is implementing. It is only focusing on what exactly is the operation being carried out. In abstract data type, data structure is combined with its operation. Now, let's look at the abstract data type in a more elaborate way. The abstract data type is comprised of two parts: the declaration of the data and the declaration of operation. The commonly used ADTs includes the linked list, stack, queues. Now, the stacks use, for example, the stacks use the LIFO mechanism, that is the last in first out, while storing the data in data structure. The last element is inserted in the stack is deleted first. Common operations are creating a stack, finding the number of elements, etc. While defining ADT, do not worry about the implementation details. So we are only using the operations as in how we require that particular operation to be performed. Coming to the types of data or the data type categories, we can divide the data types into two: the primitive data types, or in other words, the system defined data types, and the user defined data types. The primitive data types are defined by the system, and they can be seen as integer, float, character, double, and boolean. The user defined data types, when the system defined data types are not enough, then most programming languages allow the users to define their own data types called the user defined data types. Now, in C++, a very good example that can be seen is struct. The number of bits allocated for each primitive data type depends on the programming language, compiler, and operating system we are working on. The figure illustrates the classification of data structures. The data structures can be broadly classified into linear data structures and nonlinear data structures. Linear data structures are unidimensional in structure and represent the linear list. These are further classified as a sequential and linked representation. On the other hand, nonlinear data structures are two-dimensional representation of data list. The individual data structure listed under two classes have been shown, wherein the sequential can be seen as arrays, stacks, queues, priority queues, etc., and the linked representation has linked list, linked stack, linked queues. When we talk about the nonlinear having multidimensional formulation, we say that trees and graphs are the nonlinear representation of the data structure. Algorithm. An algorithm may be defined as a finite set of sequence of instruction which has a clear meaning and can be performed with a finite amount of effort in finite length of time. Starting with an algorithm, we need to understand the structure of an algorithm. An algorithm has an input, an assignment, a decision making, a repetitive step, and an output step. Properties of an algorithm. There are various properties of an algorithm starting from definiteness, finiteness, generality, effectiveness, input and output. Let's understand this one by one. The definiteness is the steps in an algorithm that should be precisely defined or unambiguously defined. That is, we should not be having any confusion or unclear definition for the algorithm that we are using. Finiteness. The algorithm must terminate after a finite number of steps. If the process is infinite in nature, we cannot call that process as an algorithm. Generality. Generic enough. An algorithm should be generic enough to solve all the problems of a particular class. The algorithm is not formulated for a specific problem, it is formulated for a class of problems. Effectiveness. The operation of the algorithm must be basic enough to be put down easily. That is, it should be very much easy to understand, and the operation should be basic enough for the generic problems that we are intending. The input and output. We have already seen that in the structure of the algorithm, we have the input and the output, and the initial and precise output may be generated both at the intermediate and final step. So it is not necessary that we receive the output only at the final of the algorithm. We can certainly have intermediate results. That is all from today's episode of 1 of 100 of data structures and algorithms. If you like my content, do not forget to like, share and subscribe to my channel. Hit the bell icon for all the notifications from Priyanka's Learn It Well. Thank you.